talk you through the ins and outs of writing a report. So a report has a definite structure, and you really should stick to this structure, this ordering. For some reason, since people have been typing up the reports, they've sort of moved the ordering. The ordering is important, so do not, it's really easy to write things in a random order and then rearrange it. It should be in this order because this order makes logical sense. So I'm going to emphasize a question every student wants to know: how long is a lab report? And there's no answer to that question. I've seen brilliant short lab reports, and I've seen absolutely dreadful long lab reports. So, just try and stick to what the instructions tell you for each section. When you're new to it, just look at what the advice in each section is. It's in the booklet, and you can always review this video again if you're not clear about anything. And of course, ask. So very simply, you start with the title. And also record date and time. I don't know how much so the title will be given to you. Date and time is when you do the experiment. I don't know if you follow sort of what happens between the big tech companies, Google and Microsoft and Samsung and that. They're always suing each other over infringement of copyright and stuff like that there. It's remarkable how important it is, your date and time stuff. So there's evidence of when things were done and what was done. Okay, so date and time. Aim, very important. The aim is what you're trying to find out. Every experiment has a goal to it. You're trying to find out, in general, a lot of them, you're trying to find out the value of something. I'll give you an example. The first experiment you do in the next week or two will be to determine the acceleration due to gravity. Okay, now a number of you won't know, a lot of you won't know what that phrase even means. But anyway, that's your aim. The aim is to find a value for the acceleration due to gravity. Do not write a paragraph about how you're going to do it. It is just the single thing you're looking for, not how you're going to do it. That's dealt with later. Just what is it that you're trying to find? One sentence. Now, how you're going to find it is really what the theory section is about. I've already said to you that every calculation in physics requires an equation. And so if we're going to calculate some answer to find this thing, to find, say, the acceleration due to gravity, we need to know what equation we're using. So the theory section, you state the equation, and also you're writing the report so that somebody understands what you're doing. Somebody like yourself. And so somebody may not know what acceleration due to, for example, acceleration due to gravity is. So explain the thing you're measuring. So I would say put in a definition. And again, I'm not going to, you're new at this. I'm not looking for a lot. Just write down, you could have a sentence, the acceleration due to gravity is, what it means. What does that phrase mean? And you could write the equation you're using for the experiment. Okay, that's it. One line and the equation. 5, a diagram. This is something that most things here are easier when you type them. The diagram is a bit of an issue. One thing you can do is take a photograph, use your smartphone, take a photograph of the equipment, and then import that into Word and have arrows coming in, labeling the elements of the experiment, the important elements. Okay. 6. Now, all of that's fairly short. This is where you have to write, say, a paragraph. So the method is how you did the experiment. Now I'm emphasizing did. It's past tense. I will give you a set of instructions. The booklet has a set of instructions. Do not write that in for a method. A method is what was done. It's written in the past tense. And I'm not going to be a big stickler on this. If you've got somebody else as a demonstrator or lecturer, they may have different things, but try to avoid I or we. If you have I or we in there, it can be I did this, I did that, I did the other thing, I did this. It's just very repetitive. So to avoid that, we turn the sentence around. We use what's called the past tense passive voice. You say the length of the bench was measured using a meter stick. The mass of the block was obtained using so it's everything was done. Okay. Now, unless if you put in I or we, that's not hugely important to me. The important thing is you write in the past tense. You record something that has happened. There's no point in you having a soccer report in which the person writing the report explains, gives Messi a set of instructions. It's about what happened, okay? Not a set of instructions. The one thing that I'll be writing a lot on your lab books, most people make this mistake, is do not give a list of instructions here. Okay, 7, data. You're taking measurements. They'll be recorded and generally they'll be in the form of a table. Okay, you'll have this all done. The data will be done in the lab. Okay, that you'll have that finished by the time you leave the lab. As I hope you'll have part 8 as well, the graph. Not every experiment contains a graph, but a number of them do. And again, it's not that difficult to produce. We'll come back to that. 9 is result. Show your calculations, and then give me the true value plus percentage variation. Okay, so in an experiment, you have a name. We're trying to find a value for something. This is where you get your value. And okay, they are not going to be the same. It will be a huge fluke or a huge, well, unless you do the experiment brilliantly. I think I've come across a couple of times in 30 years when somebody's got the right result. So don't expect to be getting the right result, and don't beat yourself up if you get the wrong result. The final part of a report is the discussion. Okay, so I'm just going to move away from that now and come back to me. So what's the discussion? The discussion is where you explain why you got it all wrong. Okay, it is a way of looking at analyzing what has happened and saying, okay, here's the true value. This is my value. The reasons why I didn't get the true value are. And just talk through the possible reasons. Now this is a hard thing to do. The discussion is the hardest part of the report, I would say, to write. But it's important to think critically about things. What I don't want to see in the discussion is, I enjoyed doing this experiment. I thought it was really good. Okay, I don't care. I do care. I want you to enjoy what you're doing. But I really don't want you to write it down as a discussion. That is not what it's there for. The discussion is to talk about why there were inaccuracies in what you did. And of course, the first thing you can write in any discussion is every measurement is inaccurate, because every measurement is inaccurate. You can't measure something absolutely perfectly. So that's what I would say about the discussion. What do you put? What else do you put in there? Well, we need an example of an experiment first. So when you're in the lab, I will mention reasons why you're not getting the right answer. Okay, we'll talk about those in the lab. But a simple example would be, you know, I look at my watch to see what time it is. That's an experiment. I've got an aim. I want to know what the time is. Okay, it doesn't involve much calculation or anything, but I glance down, look at my watch. Now, say I get the wrong time. I get the wrong time. Normally, you'll get the right time, but okay. Why would that be inaccurate? What would cause that to be wrong? If you think about that for a minute or two, you might think, well, okay, the battery's running down and the watch is running slowly, or the watch is stopped, or it could be that you borrowed the watch from somebody else, or you checked somebody else's watch and their watch was 5 minutes fast because they always want to be on. They're always late and they wanted to be on time for something. Or it could be that you've just crossed the time zone if you want to get really sort of funky about it, or you've been to Spain, you've come back, you've forgotten to do it. The clocks change at the end of October and the end of March. Maybe you forgot to change back. There are more reasons there if you think about it long enough. Now, I've been thinking, when I meant to use that example 2 days ago, and I could think of 3 things. Now, when I use the example, I can think of 5 or 6 things. So as you think about something, the possible reasons occur to you. Okay, so the discussion involves a bit of thinking. Okay, and no student likes that. Actually, not many people like that at all. So, but I'll give you some examples, and then do your best with it. See if you can come up with anything. I put a lot of emphasis when I'm marking a report on the discussion. So do spend some time. Actually, one of the best times to think about your discussion is when you're doing the experiment. You're there, and it tends to be the things that you're troubled by. You sort of think, oh, I don't think I'm doing this right. I don't think I'm measuring that. That's very awkward. Those are the things where your inaccuracies come in. Okay, so don't run away from an inaccuracy. Embrace it and really think about it. And you might say, why do I have to do this? This is nothing to do with computing. This is everything to do with computing. Particularly if you're programming something, you want to make sure you get it right. Whoever programmed the Leaving Cert results, they didn't obviously analyze and critically assess what they did. They probably went home and said, oh, I'm really pleased with that. That was really good. I enjoyed that. That was great. That was a great wee program I wrote there. But it gave the wrong answers for however many people it's going to give the wrong answers for. So that's not much use. Okay, so that's what the discussion is about. And don't be too pleased with yourself. Don't blame yourself, by the way. Sorry, when you say don't be too pleased with the experiment. Don't be too pleased with how it's all worked out. Don't be congratulating yourself on it. It's I don't want you to sort of be, there's a positive, I love positivity, but sometimes you just got to say, look, this didn't work out very well, and the reasons why it didn't work out very well are this. And I would be delighted if I saw somebody started talking that way. I think it's maybe not a healthy way to live your life for all day long, but when it comes to thinking about work and thinking about how you can improve things, you have to look closely at stuff and see what's going on. Okay, I've said too much about that. Graphs. Okay, so Excel. Let me see. Can people put their hands up if they've used How many of you have used Excel before? Okay, no, there's a few hands and a few shaking heads. Yeah. So that's grand. I'm not expecting you to have seen Excel before, but I'll just talk you through it. Okay, so share screen, which is I keep forgetting about. Right, so what we have here is an Excel sheet. You open Excel, it would normally not have anything in it, but all I've done is typed in some numbers into each box here. Each box is referred to as a cell. Okay, and you can see I've clicked on a cell there, and it's in column F, and it's in row 6. So each cell has a reference, an address. So that's F6, and you can see that address up there. Okay. Excel is great. Spreadsheets are great for doing calculations. So if I go to *8 and hit enter, what result will I get? Well, nothing changes. I get 2*8. Okay. Because a lot of the time you just put text in. It treated that as text. Star, by the way, in Excel means multiplied by. However, if I tell Excel that I'm going to ask it a question, I'm going to make it calculate. So to get Excel to calculate something, you need to put in an equal sign. Okay, it's now going to calculate. So if I go to *8, and you'll be shocked to hear that 2 times 8 is 16. And okay, hoorah! Big deal. You all did your 2 times table. You all could use a calculator to work it out, whatever. Okay, but Excel comes into its own even with doing simple or hard calculations, but doing them repetitively. If you had to do 1,000 2 times somethings, that gets a bit wearing, and you're likely to make mistakes. But Excel can do that sort of repetition very, very handily. Okay, so what you're going to use Excel for is to plot graphs. Okay, and I've put some data in here. This data is taken from a problem that is listed in your workbook. Okay, you don't have a copy of the workbook. It's on Moodle, and you'll get a copy of it when you come into the lab, as I said. So this is an experiment that someone did, and they measured the voltage. They adjusted the voltage and measured the resultant current. Now, I'm not expecting you to know anything about voltage or current. It's just a random example. You'll do this experiment later on in the semester, by the way, but it's just a random example. Voltage and current are both to do with electricity. So the voltage was varied, and they measured the corresponding current. So you set the voltage to 6.1, you measure the current. Set the voltage to 8.9, that changes the current, and so on and so on. Okay, it turns out we want to plot voltage against current. So how do we do that as a graph? Well, we select the data points, not the headings on the table. Okay, just the data points. And look, one thing to say, there are no units in here. Put the unit at the top of the column of the table. Do not put any units in here. Another thing is do not go insert table. I think you can do insert table or something in Excel. Just type the information in. Type the voltage in volts and then write down the numbers. Then type in current in milliamps and write in the numbers. Nothing fancy here. Select only the data. Okay, now we're going to plot a graph here. I would say that if I was doing this by hand, it would take me to plot a graph and work out the slope of the graph would take maybe 3/4 of an hour, half an hour, 3/4 of an hour, particularly if I want it really neat and really accurate. Okay, I'm probably going to I'm going to take a long time over this and to explain to you the various steps, and it would probably take me no more than 5 seconds. Ooh, not 5 seconds, about 5 minutes. Okay, so insert. I want a chart and I want a graph. Now, which of these do I use? Well, you can see there's lines here, which is good. You have lines in a graph, but it's not a line chart. It's the one that's got the axis. There's only one here that's got an X and a Y axis. And this is called a scatter graph. The options there are shown. And for a lot of the time, all you'll do is show the points because we're going to add on our own line to the graph. So we're just going to show the points. So there's the graph plotted. A graph needs a number of, it needs to be labeled. It's been a long week. The voice is going. Sorry. So chart title, just click there and start typing in the title. Now, I would just use the title of the experiment, which is Ohm's Law. I've typed that in and I hit enter and it appears in that place. Now I need to label the horizontal axis and the vertical axis. Actually, before I do that, one thing you need to check. When you plot a graph, whatever's on the left-hand column should appear horizontally on the graph. And whatever's on the right-hand column should appear vertically. All right, that's the way Excel works. So if I always check that that's been done correctly. So 6.1, if I go across horizontally, the first point seems to be around 6.1. And vertically, the first point should be at 1.2. And then if you hover on that point, you'll see 6.1, 1.2. So it's been plotted correctly. Right, so I'll click into the graph again. Now, all the extra things that I want to do, I want to have a horizontal label, I want to have a vertical label, and I want to put a line on the graph. All of those things are visible through, first of all, either the plus here. If I do the plus, you'll see all the list things that I want there. And so why not? We'll just use that there. So axis titles. So I'll do the primary horizontal first. And you can see that the axis title appears down at the bottom. I don't have to click in that box. I just start typing voltage V. I have to have the name of the quantity and the unit. Remember, units. And it turns out that voltage, the unit for voltage is volts. It's kind of a weird one. Hit enter, and that appears in my graph, and everything automatically resizes. The axis title vertical, well, I can go through there, but I have a particular, well, sure, I'll go with that. Okay, primary vertical thing, I can do current milliamps, enter. Now, I have a particular bee in my bonnet about this. If you want to leave it this way, fine. I always find that I have to twist my head around to read that. So I like, and it's only, it's a quibble of mine. I go to more options here. And I'm going to, again, select that box. And over on the right-hand side, it says Format Axis Title. If I go to the right, the third of the three kind of icons here, one of the things that appears here is text direction. And I can make that horizontal. And I think that's much easier to read. And again, you'll see everything resizes automatically for you. So it's really handy. Right, that's my labeling done. The last thing I need to do is the line. So the line, grid lines are already on this. So it's not grid line that gives me the line, it's trend line. So what are we going to go for here? Well, linear would be good, but Excel can give us more than that. So we go down to the more options. Okay. And like as I say, linear, you can see the straight line has appeared on the graph. It's pre-selected. And if I scroll down, one useful thing that's more closer to the bottom is display equation on chart. And that's my graph done. Now I took a look and I did start drawing the graph with the graph at 11:45 and it's now 11:50. So it did take me about 5 minutes. Okay, much quicker than it would do if you were to hand draw that. Okay, so why did I need the equation? What was the point of all that? Okay, so I'll just stop screen share for a moment and talk you through that. So we're going to go back to my lovely whiteboard here. And remember, we want an answer out of this experiment, a result. And it tends to be, if you're plotting a graph is a great way of obtaining an answer from an experiment. Okay, so when we did that, when we looked at that, the equation that came up was 0.9009x think I have as -5 or something like that. Now, how does that help us? Well, you should probably have come across y equals mx plus c. This is the equation of every straight line with y and x axis. If we compare these, so first of all, it's important to be clear what m and c here represent. M is slope of the line and c is the intercept. That is where the line meets the y-axis. So in our case here, there's our axes. The graph, I'm just looking for a different color. Yeah, maybe, hopefully you see this. Okay, so there's our line. The slope there is how that, and this is the intercept where it hits the y-axis, and that's -5. So c is -5, and hopefully you can see from here, m must be the number before the x. So that thing there is m. So the slope of my line is 0.9009, or the gradient if you're more used to calling it gradient. So by Excel has plotted the graph and given you the slope and everything in quite a few simple steps. And generally, you use the slope, then you have one final stage in the experiment. You use the slope to get your final answer. Okay, now have I any questions? I'll just pause recording for that. Okay, so there's a problem with what we've done up to now. And I'm going to reshare the Excel screen with you. And the problem is one that I've already mentioned in lectures. Units. You see that there's a milli there, a milliamp. Milli is a prefix. And if you want to do a calculation, you should really replace the prefix before you do the calculation. And where have we done the calculation here? Well, Excel has done a calculation in working out the equation of the straight line. Okay, and I'm working out the slope. So I'm going to delete all that. I want current to be in amps, not milliamps. Okay, again, don't worry if you didn't spot that. You know, nobody spots this. If I ask every year, where is my problem here? Nobody spots it, so don't worry about that. So I need to convert milliamps into amps. Milli means thousandths of an amp. So it's a tiny fraction of an amp. So I've got to divide that by 1,000 basically. Now, we want Excel to do a calculation to create it, so we could just put in equals. To do a calculation, you have to put equals first. Then you just click in the box. So it's now B3, that 1.2, and I'll type in 1,000. Okay, enter, and it becomes 0.0012. And so what? Exactly, you know, you can do that in your calculator. The advantage is, though, the fact that I put in B3 there means I can get Excel to do this all for everything in this column. For all of these values, convert it over here very, very quickly. So if you look here, the cross, the cursor is a cross, and it's an open white cross. If I go to the bottom right-hand corner, it becomes a solid black cross. I click and drag, and it has now computed all of those. Okay, I've worked with things where you've done 200 of these in a column, and it just does it sort of straight away rather than you have to work it out each time. So it's a very, very quick process. Okay, so now I want to plot a graph of voltage against current. And you'll see that if I select the voltage values, when I go to select the current values, the voltages are no longer selected. So this is a problem. You might think, well, one way you could do that, but that's 3 columns of data. You only have 2 axes on your graph. So Excel can't, you know, it doesn't make sense that, and it won't produce a sensible graph. So what you've got to remember, you select one column if two columns aren't touching each other, select one column. I'm now going to hit the Control key and hold it down, and then select the other column. So now I've got my two columns selected. Now I'm going to look at the time now, and I'm going to show you that I can probably draw this graph now in less than two minutes. Okay, so this is to show you, this is a speeded up version now. So just to go through the whole thing, how do I start? Insert. I select a chart. It's an XY scatter, only the points. Click on the chart title, Ohm's law. I won't actually go through the two things. Well, okay, I will do the axis titles. We'll do the horizontal first. That's voltage in volts. Axis title, primary vertical, more options. Okay, something didn't work there. All right, so yeah, let's do that. Okay, so again, current in amps. Right, now I'm going to turn that around. Okay, again, it's the third icon at the top over the right-hand icon. Change the text direction to horizontal. Oh, yes, of course. I need to select. I have to make sure I have the correct axis title highlighted here or selected. Text direction, go to horizontal. Right. Okay. By the way, the plus only appears if you click in the graph. If you click over here, you don't see that plus. So plus, and now trend line, more trend line options. Again, I need to be on the right-hand icon of these three here. That sometimes can catch people out. You need to be on the right-hand one. Linear, display equation on chart. And there you go. You have your equation, and you can move that up to some place where it's not in the way. Graph done. That took me 2 minutes. Okay, and that was with a bit of messing around. So like, it's a very quick process. If you practice this, if you try it for anything, it's very, very straightforward. Now, one thing that you'll want to do is import this into your report. So how do you do that? Well, it's very, very simple. Before I do that, okay, I'm just launching a Word document here in the background so that I have something to put it into. Right, that's worked now. Right. Okay, so I select the graph. I go Control, the shortcut is Control C for copy. You can do other ways if you want. I always like to hit Enter a couple of times in a Word document to move me down from the top, the space above it, so I can put other things in easily. So I'm going to put graph here and Control V for paste. Okay, there's my graph. Click on the graph, and I'm going to center it on the page. Okay, graph in. Now the data, again, go, oh, sorry. Yeah, I'm confused now. Can you see this? Can you see the Word file? We can't see Word. No. Okay. Sorry, I just realized. Yeah, I would stop. I need to. Yeah, I need to share screen each time I'm doing things. Okay, no problem. We'll go back over that. Okay, so I'll share the screen with you now. Share screen. Apologies about this. So what have I done? Oh yeah, so I've copied the graph. I'm going to, oh yeah, just put that there. I've copied the graph. As I say, I hit return a couple of times, give the title graph just, and then I'm going to do Control V to paste that in. Click on that, and center it on the page. Looks pretty well there. Next, I'm going to stop share here, open the Excel file and share that with you. So the next thing I want to do is this table here. I want to bring the data table in. So Control C again to copy it into Word. Again, I'd call it the data set. This is the data section, so we'll give it the title. Control V. Okay, and it's there. Oh shoot! Sorry, I'm losing the run of my elf. Sorry. Right, we'll go back. We'll go back. Okay, so I've copied that table. Right, I'm going to go to Word. I know, yeah. I'm going to share screen. Oh my word. It's been a long morning, would you believe? Share. Okay. So I'm now sharing the Word screen. So we put in the data label and Control V gives you the table. The table's a mess. It doesn't look, that's not professional. But thankfully, Excel will, or Word can help us out here and make us look much more professional. If I hover in that table, you'll see that a box with a cross appears up in the top left-hand corner. So I select that, and because I'm looking at a table, you'll see up here, table design and layout appear at the top of the screen. Okay, so if I go to table design, I can have any layout of table I want. There's a huge selection there. Okay, so what will I go with? I'll go with yellow, this or whatever that color is. Yeah, yellow. Okay, looking an awful lot nicer all of a sudden. I don't like this thing where the voltage and volts are appearing on different lines. So if I go to the dividing line between the two columns, can you see that the cursor just changes to parallel lines with two arrows pulling in different directions? If I double click there, the thing opens out, so voltage and volts all appear in the one thing. Again, I'm going to do the same here. It's a bit fiddly. No, it's decided not to. Oh, it doesn't want to work. Okay, I can shift it up here. Yeah. And similarly, hopefully that will work. No, it stopped working on me. It was working before, but it stopped working. So again, you can shift it up. You can shift the edge up at the top there, just underneath where it says table styles, and I can widen that out. Okay. So the table looks grand now. And again, you can highlight it all, home, and center it. And really, you want to have that done before you leave the lab. Putting in the table and putting in the graph and getting the graph done takes you sort of just a couple of minutes. And that's 2 sections of the report done. You should also know what your result is. And once you've got all those bits, you're just filling in the rest then after that to give you the full report. Okay, so I'm going to stop share there and I'm going to stop recording.